All right. Well, again, good afternoon, everybody, and I'd like to welcome you all to today's webinar. Today's topic will be asphalt maintenance treatment options. Before we get started, I wanted to touch on the webinar controls that you see on your screen. All attendees are in listen-only mode, so you're all muted at this time. The questions pod, which you should see towards the top right of your screen, is where you will type any questions or comments that you have. Feel free to use this at any time, and we will have several points during the presentation where we will stop to address those questions. Finally, under the materials button, which you should see right next to the questions pod, you should have one handout. This is a copy of the presentation, and you can click it to download for future use. My name is Tally Faulkner, and I will be handling the technical support for today's webinar. If you have any issues during the webinar, you can reach out to me in the questions pod, or you can email me at arltap@uark.edu. The instructor for today's webinar is Stacy Williams. Dr. Williams is the director of the Center for Training Transportation Professionals and is also on the faculty of the Civil Engineering Department at the University of Arkansas. This webinar is sponsored by the Arkansas LTAP program, and Patrick Thomas with RDOT is the program manager within RDOT. Today's webinar will generate 2 hours of Road Scholar credit through the Arkansas LTAP program, and you will receive a certificate which will probably be mailed to you by the end of next week. Keep in mind that you must attend the full webinar to receive a certificate. Finally, if you have a group attending with you today, please let us know who's attending with you so that we can make sure all attendees receive a certificate. To do that, please send an email with your list to arltap@uark.edu. And you see that email towards the left middle side of your screen. And with that, I will turn it over to Dr. Williams.
All right, good afternoon, everyone. Welcome to the webinar. We're going to be talking about asphalt pavement maintenance and specifically some of the treatment options that are available. And to get started, I want to pop a poll question up on your screen and get a feel for who all is out there and what types of treatment options you currently use. So which of the following does your agency use? And the choices are fog seals, chip seals, slurry seals, microsurfacing, and ultra-thin bonded wearing course. It should be available for you to select all that apply, so you can pick multiple options. Look like from the registration list, we had a pretty good cross-section of folks from different areas of the country, so probably a lot of variety in answers that will be coming in. I'll give you a few more seconds to finish answering that poll. All right, a few more are still coming in. All right, I'm going to go ahead and close that poll so we can get started. It looked like so every option had some folks that were actually using each of them. The most popular one was ultra-thin bonded wearing course, so we will get to that. That'll be later in the presentation. But let's get started out just talking about maintenance in general. So for asphalt roadways, we obviously have to do maintenance. They don't last forever. But if you look at the word maintenance, what does that mean to you? I think maintenance means a lot of things to a lot of people. And if you work for a road or street department within a local agency, on some level, it probably means job security. But to maintain the roadway means that we want to repair it or keep it in working order. Our job in public agencies is to continue to serve the traveling public. So we're trying to make sure that folks can get from point A to point B in a reliable way. But there are different types of maintenance. So there's corrective maintenance, and that may be what we're mostly familiar with, is that we kind of wait till there's a problem, and then once we see that there's an issue, then we go and fix that thing. So that would be corrective maintenance, where we're reacting to a problem that has already happened. But there's also preventive maintenance, and this is where we take some actions to prevent a problem that actually has not occurred yet. So if we can do something to keep that problem from happening, then that's going to be better for the traveling public. And then preservation takes that a step further to make sure that we do everything possible to keep those problems from occurring at all. Um, so as we talk about these different treatment options, it's not just fixing something that's broken. Think of these as something that is something preventive that we can do. So that preservation, pavement preservation, early on being proactive in our strategies for maintaining the quality of the roadways. It's kind of like going to the dentist. We would rather go and have those regular dental checkups and cleanings to keep from having cavities, because it's a lot more expensive to have cavities filled or have a root canal done. It's a lot easier and much less painful to go through those regular cleanings. So same kind of thing applies to our roadways. All right, so we need to know, if we're going to keep problems from happening, how do asphalt roads actually fail? One of the primary ways is by rutting. So asphalt pavements are flexible pavements. They do have some flex to them. They can move around a bit, and that obviously can result in rutting. But the other way that they fail would be cracking. Since they do flex a little bit, we put loads on them in terms of traffic. The They can only bend so far before they break. So those would be our cracks. Now, in terms of rutting, we might have mixture rutting, we might have subgrade rutting, and those may look the same or similar on the surface, but can be indicative of a different problem that's actually causing them. And then there might be some related distresses like shoving or stripping. And then in cracking, the most common thing that we see that really stands out is, wow, that's some bad cracking. That's usually fatigue cracking. But we might also see thermal cracking, edge failures, joint failures, and some of those other types of things, even slippage cracks. Now, asphalt binders, the oil that goes into the mix, is dependent on temperature, very much dependent on temperature. So not just when we make it, we heat it up, it's more of a liquid. When it cools down to ambient temperature, it's more of a solid. But also we need to take into effect the traffic and the climate. And the climate temperature range is also going to affect how those oils will perform. Current mixes typically, in most of the country anyway, are using performance graded binders, which means that we've assigned some qualities of that oil to how well it performs under certain conditions, specifically temperature. So from a range of temperature of a low temperature to a high temperature, if it is graded for that temperature range, we expect it to behave well and do what we want it to do in that range. So that will vary by climate depending on where we are in the country. And then we can also make some adjustments to that for traffic expectations. Now, performance is really the key to it, because that's what we're after, is get something that will perform well. So when you look at those binders and how that interacts with the aggregates that are in the mix, what we see is that we're more likely to have rutting types of failures at high temperatures and more likely to have cracking failures when we have low temperatures. And when we have failures, those can be non-structural and they can be structural. So part of deciding how to fix a problem is figuring out really what kind of problem it is. Where did it come from? Not just how can I put a Band-Aid over the top of it, but root cause. Where does this problem start? How deep into the pavement structure do I need to be really targeting my fix? So if I'm lucky, then maybe some of my issues are non-structural. So there might be some transverse cracks in the roadway. Those would be the ones that run across the road, so they tend to be shorter cracks. Longitudinal cracks can be longer. They run long ways in the direction of travel. But if those are not in the wheel path, then chances are they may be related to something other than traffic loadings. Traffic loading types of failures are going to tend to happen where those loads are actually physically contacting the pavement, which would be in the wheel paths. If we have transverse and longitudinal cracks that start to connect, sometimes we'll see something called block cracking. It just looks like a bunch of big squares in the road. They can be anywhere from a foot or two square to maybe a 10-foot dimension in either direction, but it does make that pretty regular square pattern. And then we might see things like raveling or weathering, bleeding and flushing, maybe mixed rutting, and all of those things are really items that tend to respond well to surface treatment. So we can do something at the surface level to fix those problems. On the other hand, if we have structural failures, that's something that indicates that the problem is much deeper within the pavement structure. So the longitudinal cracking in the wheel path, that means that the traffic loadings in the wheel path are showing up as, hey, this pavement wasn't strong enough to hold up these loads, and it bent until it broke. And so now we're seeing those cracks. We might see alligator cracking or severe fatigue cracking. Everybody's familiar probably with that term. It might be that we have base failures. That could be something under the asphalt layer that's not so good. We could have pumping. A lot of times we'll see kind of that dirty look after a rainfall. We've got traffic on an area that's got a lot of fatigue cracking, and we see that dirty kind of leftover residue that's in that cracked area. That's actually subgrade material, or at least base material, pumping up through the surface. And then if our subgrade is soft, we may have some subgrade rutting, which means way down deep in that structure, the foundation of our pavement structure is kind of failing or softening. And so it moves or compresses, condenses, everything moves downward. And then what we see at the surface looks like a rut. But it's not just the mix that's rutting, it's way down deep in that structure. So the deeper the problem, the deeper the solution, and the deeper we go, the more expensive it is. So with our pavement structure, timing is very important. We hope that the distresses that we see are going to be limited to non-structural type failures. Those are the ones that are, limited to the top section. And if we can fix them in a timely manner, then that's great. That is the cheapest way to address that for the most part. But those non-structural problems, if we don't do something about them, they're going to let air and water get down into the pavement structure, and eventually they're going to become structural problems. So if we wait too long, it's going to cost us a whole lot more money. So looking at what might happen, if we start looking at those openings in the pavement surface where we have some cracks, and that allows water and air to get in there, it starts to affect not only the surface that we see, but it really can be affecting the entire structure all the way down into that subgrade. And the longer we wait, the deeper the problem goes. So the question becomes, how do we fix it? Well, one option is we see a little bit of a problem and we think, oh, that's not that bad. I'm not going to do anything about it right now. So do nothing is, of course, always an alternative. And it might be a choice that we have to make if we don't have the budget to do the things we want to do. Sometimes we can make a lot of headway toward a problem or toward fixing a problem if we just look at drainage. If you can change the drainage patterns and keep water off the surface, out of the roadway, out from under the roadway, and just keep it away from that pavement structure, we're going to go a long way in preserving the life of the pavement. And then pothole patching, crack sealing, those are some of the things that we can do that are pretty basic. If there's a pothole, for safety reasons, we really need to have that filled, but also a pothole. The name pothole indicates that there is a hole there. So that's the lowest point in that pavement surface, most likely. Water goes to the lowest point. So if we know that there's a pothole that was the weakest point in the pavement already, and we've now created kind of a little basin or holding tank for more water to do more damage in that location. So the longer we leave that pothole open, the more quickly we're going to see that deterioration. Same thing with cracking. The more we leave that open, the more we have a location for water to infiltrate the surface, and those cracks will tend to get worse. So if we can patch those potholes and seal those cracks, we're going to be a step ahead. We might choose some wearing courses. Maybe we want to treat the entire surface, And so that's definitely an option. Kind of a typical traditional thing is when we have a pavement that over so much time has started to deteriorate, it's not in such great shape, we get to a certain point and then we do an overlay. So we cover up everything that's there. If we wait too long, or if that overlay is not substantial enough, we may have to do a complete rehabilitation of the pavement. So rehabilitation and total construction end up being the things on the list that are the most expensive. They involve the most effort, the most materials, the most everything, definitely the most money. So what we want to do is focus on some of those wearing courses and give you some new tools in the toolbox, because that's where I think that we can save ourselves some heartache and some dollars in the long run. So if we take our little tiny toolbox and we have more options, then we end up with a much larger toolbox. So that is something that, we're going to talk about a lot of things. And for whatever reason, there's a multitude of reasons that some of those things may or may not work for you or may not work in certain situations. But even if you think, hey, that's something that really is not going to be an option for our agency, keep it in mind. There might be a situation at some point where you're like, normally I wouldn't select this, but this time maybe it's a good idea. So keeping those tools in the toolbox is always a good thing. All right, the first segment, surface treatment that we're going to talk about, it's kind of the smallest, cheapest, easiest version. It's kind of a minor treatment that we can do. It's called a fog seal. So I am going to go to the poll question and get a gauge for how many of you are familiar with fog seals. All right, looks like most of those votes have come in. Got a few more answers trickling in. And the votes are actually very well distributed. We've got about a third that say yes, a third that say somewhat, and a third that said no. I'm going to end that. We'll go back to the presentation. So what a fog seal is basically just a light spray of a dilute emulsion. And we're going to put that on some type of an asphalt surface. So if we add that little bit of spray, we're just coating the surfaces with something very light, but it's something that is going to help make that surface more impermeable. So that little bit of an oil coating hopefully will seal up any of the micro cracks, anything that we're starting to see. It helps rejuvenate an aged pavement, but we're adding some asphalt to the surface. So when we have an asphalt mix or any type of bituminous product, basically we've got rocks and we've got oil. The rocks give us the structure, the oil glues it all together and keeps it in place. But that oil over time will age. It becomes brittle. Sometimes that's the source of some of our cracking, because that oil, that elastic type behavior of the oil, that's really what makes asphalt a flexible pavement. So when it ages, it's not so flexible anymore. And one of the things a fog seal will do for us is give us a little bit more oil to kind of pep that back up. So in sealing, it is a seal to some extent. It's a very thin coating, but it can seal or waterproof the surface and help close up some of those really small cracks. And this is not something that's going to be a magic, I'll fix these giant cracks in the road for a really cheap cost. It's not going to do that much. But if you get out and look closely, you can see when some of the micro cracks and the smaller than 1/8 inch cracks are starting to form. And you see it just overall has that aged look. You're starting to see some distress, and this fog seal can help slow that down. So if it can rejuvenate that aged surface, slow down the aging, then what we're doing is maintaining a higher level of performance for that pavement for a longer period of time. And that's what the public wants. The other thing it does is, since it is an oil, kind of a film that goes on there, it does have that dark appearance. You can see in the picture here, the main 5 lanes of that roadway have been fog sealed. new striping put down, and it makes it look newer. The striping is more visually striking. And in contrast, you can see the little side street right down in the bottom of the photo. It's got the older, aged look to it. So all of it looks like that, but then those main lanes on the primary roadway were fog sealed. Now you can put this on a number of different types of surfaces. You can do this on an asphalt surface. You can also use this on a chip seal. Sometimes we have trouble with raveling or losing some of the stone. This can be a coating that helps sort of glue that down from the top and make it more impermeable as well. Now, the best case scenario is that we use a fog seal on a surface that's got plenty of texture. And I'll tell you why. Mainly because if you don't have enough texture and you put a coating of oil on it, you're just going to make the road slick. So we have some skid problems, skid resistance issues. If you have a really, really tight, closed surface and there's not much texture, there's nowhere for that oil to go. So make sure that your surface does have plenty of texture. Now, a typical dense graded, say a half-inch surface type mix, generally will have enough texture to it to handle this, but this is something that you would need to work with your producer, whoever is going to be doing the work. They can do a design for you and make sure you get the shot rate appropriate. And then if you have a chip seal roadway, obviously that's got a lot of texture and it can take a higher rate that you apply and it works fine. So just make sure that you gauge that rate appropriately for the type of surface that it's on. Now, open mixes, while they do have a lot of texture, they can help with skid resistance. They also have a lot of surface area, so those are typically the ones that tend to age a little faster. So just keep that in mind, and that's why sometimes your mixes, this one turned gray a lot faster than that one. Maybe it was a different type of mix. One caution note on this, though, is your open graded friction courses are made to have extra friction. They're open graded, but you do not want to put a fog seal on those because they're made to take in water, made to let that flow and get off of the roadway. And if we try to seal that off, we're kind of going against the whole intent and purpose of that mix type. Right, the other thing that is critical to note is that a fog seal is not going to fix any structural problems. So this is very much a preventive maintenance or a pavement preservation type of strategy where we're trying to see way early in the process before we really have those visible cracks, that you would see as you drive down the road. This is something where you're just starting to see that aging. You look closely, you see some of those micro cracks starting to form. Perfect time for this. But if you already have structural issues, this will make it darker, might make it prettier, but it's not really going to fix any of those structural issues. Now, I mentioned that a fog seal is an emulsion product, and an emulsion is a mixture of oil and water. The first reaction to that statement is oil and water don't mix, so that doesn't make any sense. But basically what happens is the oil is the part we want. That's what gives us the adherence, the adhesion. That's the glue that holds the mix together. So for an asphalt mixture, we want that glue. We heat it up and it works magically like liquid until it cools down, then it's a solid. But imagine trying to spray a very fine film of that product onto a roadway. It's not going to work. So to get something that's more pumpable, usable, that we can use in a variety of applications, I need it to be different. So we take some water, we take some oil, and we take a colloid mill and we basically chop all of that oil into tiny little oil droplets and stir it really fast and mix it in with the water. Then we add a surfactant to help it stay in that separated state. So the emulsion form is like the diagram on the left. It's all kind of mixed up. That's when we're going to apply it to the roadway. At this point, it's going to be kind of a brown color. And then after it hits the roadway, and it starts to separate. The water is going to get together, all the oil particles are going to get together, and so that's what we call breaking. That's where all of those parts kind of separate back out to their normal natural state. And then during curing, the water is going to evaporate off of that surface and leave us just with the oil. But it gave us a way to get a very thin coating of that oil on in a manner that we could manage with less restrictions on temperature, lots of advantages to how to get that material on the ground. Now, the application rates are based on residual binder. So even though this is an emulsion, which means oil and water, when it's diluted, make sure that you communicate well with your supplier and you know what is the final ratio of water to oil. Sometimes it's already that mixture and then it's further diluted. You need to know that because all of your application rates need to be based on how much oil is left after the water has evaporated. And then there are lots of different types of emulsions, like a CRSP2. There's all kind of little code letters. There's some that are cationic, some are anionic, some are rapid set, medium set, slow set, quick set, you name it. There's a product for just about everything. The main thing that we will look at is, do we want it to set up slowly or quickly? And depending on our application, that's going to affect how that works. So for a fog seal, what we're really wanting to happen is that this light spray of oil needs to soak into the surface. So for that reason, we want it usually to be a slow setting emulsion because we want it to have time to soak into that surface. It needs to be properly diluted so that it's thin enough to soak into those spaces and then not be too thick after the emulsion breaks. Again, if it's too thick or a rate's too high, we're going to have some potential issues with skid resistance. And then again, don't put this on super dense surfaces, like some of those roadways that performed really well, but they've been out there for 25 years and they're just smooth as can be. That's not really the place for the fog seal. Now, we do have to wait for this to set up before opening to traffic. So there are lots of varieties of fog seals. There are some that are high performance fog seals. That's going to have an additive in it that will make it cost a little bit more, but it's going to allow us to open to traffic sooner. A rejuvenating fog seal is going to help regenerate some of the binder flexibility for the asphalt that's already in that mix. And that's just a little additional chemical that's going to help it bond and kind of liven up that older binder. There we go. All right, when we spray this from the distributor truck, that truck's going to have a spray bar. The truck needs to be able to heat, circulate, pump, and spray the binder or emulsion. And it's going to do that through that spray bar that's got a series of nozzles. Those nozzles need to be set at about a 15 to 30 degree angle. So they're not actually, the fans that come out are not actually hitting each other. But then at the outer edge, we're going to end up with kind of some overspray. So if you knife edge those outside nozzles, it will help make a nice clean edge for your application. And that just means turn it where it's going to spray longitudinal with the roadway. We'll see an example of that in a minute. The spray bar should be perpendicular to the pavement center line. You don't want it to be cattywampus and kind of twisted. And then we can also do a calibration of the spray bar. And one of the easiest ways to do that is take a square of carpet that's got a known area, usually a 1 yard by 1 yard area. And then we weigh that. We know what it is with nothing on it. We put that down on the pavement and then run the truck across it, spray it at whatever rate that we think it needs to be. And then we weigh that again. And the difference in weight is just how much of that emulsion was sprayed on there. So then you can figure what was that amount per square yard or whatever units you want to use. But that is one of the ways to do that calibration, because you want to make sure your rate is correct, because fog seals are pretty sensitive to changes in rate. Now the spray bar should be at a height above the surface that's going to allow for at least double, if not triple, overlap. And what I mean by that is shown in the diagram, where you've got the little triangles of the spray that fans out from the nozzle, and you've got lots of different nozzles. So those should be twisted and fanned so that the ones that are sitting next to each other are definitely going to have some overlap. And then down at the very bottom, you can see those darkest triangles. That's going to be where we actually have triple overlap. So nozzle number 1, 2, and 3, all 3 of those actually overlap just a little bit down here at the bottom. So that's what we want to make sure we get a nice even coating across the width of the pavement. So here's an example of that distributor truck headed down the road, and you can see how those nozzles are twisted a little bit, so they're not actually hitting each other, but they are overlapping as the truck goes down the road. All right, so the application rates, remember that usually an emulsion is a 50% dilution rate, which means 1 part water, 1 part emulsion. So if we're already at part of that is water, then if we dilute it, we're going to have usually more than half of it being water. Typical rates for a fog seal are somewhere between 0.03 and 0.22 gallons per square yard. 0.03 to 0.11, that's going to be the lower end of that range for your tighter surfaces, not so tight that you can't handle a fog seal, but more of your dense graded surfaces. And then if you have something that's more of an open graded or chip seal, something with more texture, you're going to be up closer to that 0.2. One strategy that a lot of folks like to do is that you can run this truck pretty quickly down the road. And so some folks like to run half of that rate in one direction and then also run it coming back the other direction. So you're hitting both sides of the pavement texture. So imagine that the truck goes down the road pretty quickly and we're hitting the front sides of the aggregates that are sticking up, but the back side is not really getting hit with that oil. It would be if you came back the other direction. So especially on chip seals where you do have a lot of texture, that's going to be more evident. And then the last thing is when you turn this loose to traffic, you turn traffic back onto the project, you want to make sure that it has cured out, and that may take a little while, but if you see that vehicles are picking up some of this, you can use a sand or a blotter coat, something like that, to keep vehicles from picking this up. Now, optimal construction season for fog seals is going to be warm, dry weather. Remember that emulsion has to cure before you have any freezing conditions. So we want to make sure that the water gets out of that material. So you want to do this when there's little or no chance of rain, and usually a minimum of 50 degrees, but I would say around 60 degrees would be a minimum pavement temperature that you want to have. So this is a summertime activity. Make sure the pavement is clean and dry. And if you have a lot of dirt or grit, a lot of dust, and there's stuff that's going to keep that fog seal from sticking, you want to run a broom truck or flush that pavement at least 24 hours prior and let the pavement dry out before you put the fog seal on it. But if you have a lot of dust and dirt on the roadway, that is just going to be a barrier between your surface and the new fog seal. It's not going to stick very well, so make sure that is clean. Then you're going to apply the emulsion. You're going to see probably it should absorb within 2 to 3 minutes, and then the standard fog seals probably within 2 to 4 hours. 4 hours should be enough to let traffic back on it. So you will have that roadway closure. If you use some of the high performance fog seals, then maybe you've got traffic back on it in an hour and a half. So it's an extra cost to have that option, but if that's important for what you're doing, then that might be just the thing you need to do. The other thing is that the weather will affect how fast that cures out. So if it's a sunny day, warm, hot weather, that kind of thing, and you're out in the open, it's going to cure out a little bit faster than if it's a cool day and you've got a lot of shade or it's cloudy, something like that. It may take it a little bit longer to cure. And your manufacturers, since there's so many different types and materials, your manufacturers will be able to help you with exactly how that ought to work. All right, again, fog seal is good for those small cracks, and we're not looking at major deterioration. In fact, a lot of folks will probably wonder, why are you out there doing anything on that roadway at all? There's nothing wrong with it, especially if someone else lives on a different road that does have some serious problems. They probably wonder, why are you working on that road when mine is so much worse? Well, because we're trying to preserve the value that we have in this particular roadway. So again, we are looking at something up to maybe 1/8-inch cracks. And remember that once you have effectively painted the road black again, you will need to restripe. So that is something that you want to remember and include in your estimate for what the project will cost. Now I've got a video here. I'm going to try to play this. So hopefully internet speeds will work and this will look okay on your end. So, oh, no, try that again. There we go. All right, so that's what it looks like. See, it has that brown color to it. After a few minutes, that will break and turn black. And if you notice, I think I've got another picture later, but that outer edge, that outer nozzle was turned so that there wasn't too much overspray on the other side of that stripe. In this case, we're going to be coming back the other direction and hitting that other lane anyway, so it's not a big deal at this point. And looking kind of up close after the fog seal has been placed and it's cured, we put traffic back on it, restriped, done all the things. This is kind of what it looks like. So you have, there are some cracks that were a little bigger than what fog seal could handle. If you notice, you can see my cursor kind of up in this top middle section. There's a little bit of a wandering crack here to the right of the stripe. And so that is something that, of course, you can still see after the fog seal, but that extra layer of emulsion is helping close that up a little bit. So it's still going to help to some extent. And then again, this is kind of what it looked like, just some other pictures of the project. And you can see, once traffic gets on it, you can see a little bit of where those wheel paths are. There is some wear. The tires will pick that up a little bit. Just over time, that's the wheel paths are probably where you'll see it wear first. All right, in terms of troubleshooting, some things that can go wrong. If your surface is slippery, you want to check and make sure that the emulsion was diluted properly. Did it set too quickly where it didn't really soak into the texture of the surface? Did you have any rainfall that happened too soon after placement? Sometimes that'll wash the emulsion back out of those pores and onto the surface. So just make sure that you are doing this in best possible weather conditions, and then you can apply some clean dry sand and then broom that off, but that will help kind of soak up that extra. If you have bleeding or flushing, that just means there's too much oil on the top. Be sure and check your application rate. It may be too high. One thing I did not mention earlier, I don't think, is that typically when you do a fog seal, the nozzles on your distributor truck on the spray bar are a different type of nozzle that can give a finer spray than what you might see for a tack coat during a paving project. So make sure you do have the correct nozzles, you calibrated the spray bar, and all of those things. And then if you see streaking, it could be that the emulsion was too cold, maybe it was too high of viscosity, which means too thick of a liquid. Make sure your spray bar is at the correct height and you've got those nozzles all at a consistent angle with the appropriate overlap. And then the other obvious thing is, Do you have any nozzles that are clogged? In terms of cost and benefit, what does this treatment actually do for you? I'm going to qualify this by all of the estimates and things that I've put together are in the context of local roadways and generally lower traffic counts. So the price ranges that I'm showing here, anywhere from $1.70 to $4.25 per square yard. That is a huge range. I understand that, so I'm kind of not giving you any specific information, but that runs $12,000 to $30,000 per lane mile. Now, part of the reason for that is what type of emulsion are you using? Are you paying extra for some of those extra goodies that are in there for the high performance? You can add carbon black to make it a nice dark color, darker than the normal. You can have the rapid setting or the high performance that you can turn traffic back on sooner. Maybe it's more of a rejuvenating content. So there are lots of additives that can be put into the product. And then also, do you do the work in-house? Do you contract it out? Usually, if you can do this work in-house with your own equipment, then the overall cost that you're going to see is much less than if you were to contract this out. Pavement life extension, what does this do for you? Well, if you have an asphalt surface that's say 1 or 2 years old, it's in good condition, there's really nothing wrong with it, but you're starting to see that lighter gray color show through, so it looks like it's aging. You know, when it's brand new, it's nice, it's a sharp black with a good contrast between the asphalt surface and the striping, and then over time it kind of turns gray, brown, whatever color your aggregate is. But after, you know, just a little bit, you see that happening, you go ahead and apply this fog seal pretty early while it's still in good condition. If you have a low traffic roadway, that's probably going to buy you an additional 3 to 4 years in the overall life of the pavement. With a little more traffic, maybe 1 to 3 years additional. If you've got an asphalt surface that's kind of aged, that's still in fair condition, it might buy you 2 to 3 years with lower traffic or 1 to 2 years with higher traffic. And then chip seal kind of depends on the actual material that your chip seal is made from, but with lower traffic, you can get 2 to 4 years. And the biggest benefit here is that you're keeping water out of that chip seal surface and you're helping with chip retention. And that's a lot of what goes wrong with our chip seals. So higher traffic levels, not quite as much. All right, are there any questions at this point?
Yes, we have had several questions come through, and if you do have more as we move along here, please feel free to get those posted. One question that I will answer real quick is, will the recording be shared with attendees? And the answer is yes, we will share it actually with everybody. It will be on our CTTP YouTube channel, and an easy way to get to that, and Stacy will have a slide, it'll be the last slide at the end of the presentation, but if you go to our website, which is cttp.org/ARLTAP, there's a recorded webinars button in the menu there, and that'll take you to where the webinar will be. And give us a couple of days and we should have it up there. But yes, we will have that and share it with everybody. Couple of the questions I have. The first one, what is the difference between a fog seal and a seal coat? Is it common to apply a seal coat after placing new pavement?
All right, a fog seal and a seal coat kind of depends on where you are and what the local lingo is. But I will comment, we talk about a lot of seals. And when I am out in, you know, different areas talking to folks, they say, yeah, we put a seal on that pavement. Well, that could be a fog seal, slurry seal, chip seal, you know, there's thousands of options there. But a seal coat in general is what I think of it as is kind of what you see on a parking lot, where the parking lot starts to look aged and a business wants it to look nice and fresh. So they have a seal coat put there. It also serves the purpose of, you know, all the things that a fog seal will do for a roadway, which helps make it more impermeable, and it just looks nicer. But that's typically going to be sprayed on. Sometimes they'll push the material around with a squeegee, kind of spread it out in some of those areas, especially up close to a curb. That is a little bit different product. It's typically a little heavier. It's not quite as light or fine of a spray as what you'll see on fog seal. And the primary issue for a roadway is the fog seal is that finer mist, and it's less likely to cause friction problems. In a parking lot, people should be going very slowly. Friction resistance, not that big of a deal. On a roadway, if you're going 45, 50 miles an hour and you have to slam on the brakes for something, you want to make sure that you have all the skid resistance possible. So the application rate, how it's applied, and how evenly it's distributed across the roadway, because it's coming through that whole spray bar that's going to even it out across the entire lane, where a seal coat, like in a parking lot, is going to be applied with a wand, and they just kind of spray back and forth and work those edges. And so it's kind of an art to it, but depending on how good of an artist, that's going to determine how consistent it is across the surface of that parking lot.
Okay, great. And we did have two people that actually asked the same question. So merging both those questions together, what I have is it recommended to remove the striping, or is it okay to fog seal over the striping and then restripe?
Usually, I think most of the time people just fog over it and then they restripe. There are some particular materials, there's some emulsions that don't work well with thermoplastic. And so for that, you might need to remove some of that. It might just perform better. I would go specifically to your manufacturer, because I think that is sometimes an issue with some specific types of fog seal.
Okay, great. Well, I believe that is everything that we have for now.
All right, very good. Well, next we will move on and look at chip seals. So I'm going to put that poll question up here and ask you how familiar you are with chip seals. So are you familiar with it? Somewhat, not at all? All right, looks like most of those have come in. We've got almost half that say yes, they're familiar with it. 35% say somewhat, and not quite 20% saying that they are not familiar with it. So I'll go ahead and close that one out. So a chip seal, the most standard basic kind of chip seal, is a single chip seal. So if we have some existing pavement or surface, what happens is that we come in with an emulsion product, and that gets sprayed on the surface. And that's a coating of oil. And then my little animation didn't go right. Anyway, we drop the aggregate particles on top of that, and those particles will embed in the surface, which means they're halfway embedded in the oil, and we roll that to make sure that it gets mashed down. And we want about halfway, all those rocks to be about halfway embedded into the surface. Now a double chip seal, we have that existing surface, and then we add oil, we add rocks, we roll that in, and then we come back with another layer of oil or emulsion. We put that over the top, and then another layer of rock. So it's a double chip seal, but sometimes what you will notice is that you might use a smaller aggregate on that top layer, just to make it a little bit smoother, a little bit more of a fine texture, a little bit closer to what you might see for kind of like an older asphalt roadway. So sometimes a double chip seal is two layers of exactly the same thing. But what we're looking for is that oil to be the bonding agent between the surface underneath and the aggregates that we're going to sprinkle over the top. So here you can see that brownish emulsion. It's starting to break a little bit, but you can see those aggregate particles that are dropped on top. And obviously this is kind of over at the edge before all the chips were spread. But just to give you an idea of what's happening, each of those particles is dropping hopefully enough into that oil layer that it will live there forever. We want it to get in there, we're going to mash it down with the roller, and we want it to stay stuck in there. But when the aggregates are all covering the emulsion, we're not really going to see the oil. Okay? It's going to be underneath. That's just the glue between the surface that we see and that underlying material. Now, project selection. First of all, chip seal is something that you typically see in county roadways, not so much city streets, but it's good to seal small cracks. A lot of times we'll see it used if they're wanting to take a gravel road and upgrade that to sort of a paved road. Then this is kind of that first step in getting to that point. It will seal some small cracks, less than 1/4 of an inch, so some decent sized cracks. And since we're putting that entire layer of oil down, it does a good job of waterproofing that old surface. Since we have aggregates as that top layer, that's what's visible, then we've got a pretty good amount of skid resistance because all the texture of the aggregate is there and available to grip to the tires. So we're really adding quite a bit of texture anytime we put a new chip seal down. So if you have a roadway that's got raveling, bleeding, flushing, anything with too much oil, then this is a great layer that you can put down to kind of separate that oil that can be slick and separate that from tires. It helps retain the stone because we've got, that glue there putting it all together. And then of course it's also going to slow down any pavement aging or oxidation because we're completely covering that up. You can do this, like to upgrade a gravel road to a chip seal road. That's usually going to require a double chip seal for your first go at it. But there are lots of cases where we've got a paved road that's had a traditional hot mix surface and it's just not doing that well, and we don't have enough funding to be able to come in and do a full overlay, but you can do a chip seal. And so it's still going to help preserve the structure and the surface that was there before. It's just going to look different, have a little bit different texture. The thing it will not do is correct major cracking issues. It's not going to do a whole lot for those structural failures like fatigue cracking, any longitudinal cracking in the wheel path. This is not going to be strong enough to counteract that. The biggest complaint about chip seals, I think, is that it's a rougher texture, which again does give us more skid resistance, but it can be noisy. And it's not quite the same effect as a paved road. And it looks like gravel on top. A lot of times folks will say, why are you, if we had a paved road that we're then putting a chip seal on, they say, why are you turning my road back to gravel? Well, it's not gravel. We've got a layer of oil there. It's all getting glued together. But it's something that can also be done much more quickly than an asphalt overlay. The curing time is a few hours, but you can move much more quickly with this process than you can with a paver. And the materials, of course, we're going to need an asphalt emulsion. Polymer modified emulsions can be used to get better performance. We do want this to be a rapid set. We don't want this soaking down into the underlying texture of the roadway. We want this to stay on top, and we want those aggregates to drop in, and we want it to grab them real quick and set up right there. This is a membrane, essentially, that we're putting on top of the old roadway. You can also do a chip seal with a PG graded binders. This will be the same kind of oil that we use in an asphalt mixture. So depending on your temperature range, your weather, it's a little bit more sensitive to things like temperature, but also if you have any moisture or dampness on the roadway, that's going to be an issue. But it's very particular on temperature and getting it sprayed down correctly without clogging up equipment and things kind of going wrong. But it's a higher quality binder. You get more oil, so sometimes you do get a much better performance out of it overall. And then some folks are using rubber modified asphalt, and that's going to be something that's just chemically modified using recycled tires. Rejuvenating emulsions are going to be modified with oils or polymers, and this is something that can help soften some aged binders and help slow down some of the existing cracking. So if you're putting a chip seal over a road that was previously an asphalt surface, but it's just gotten really old, aged, weathered, has some cracking, then this can definitely help slow that cracking down and help keep it from reflecting through the surface because it softens up what's there. In terms of aggregate, aggregate is one of the most important things about a chip seal because this is your surface. This is what you see on top. The best shape for the aggregate is going to be something that's crushed, it's angular, it's kind of cubical, kind of chunkier shape. Doesn't have to be in squares, but something that's chunkier. We don't want those flat, elongated type particles, and we want all of the particles to pretty much be the same size. So in an asphalt mixture, we want some of the large all the way down to the dust size. We have a lot of sizes that are going to pack together like a puzzle, and we're going to try to close up all those voids. But a chip seal is very different. We want all of those particles to be essentially the same kind of size. So it's going to have to be an aggregate source that's fractionated out into the size that we want. A common one is 1/2 inch. So part of what this will do for us is help avoid segregation because we can't segregate into different sizes if we don't have a lot of different sizes. But again, limit those flat and elongated particles. Some people will do a sand seal, which I think is like, I think when they say that, they're meaning like a chip seal, but they're putting sand on that. This is a skid resistance problem in a lot of cases. So this is something I would only recommend for very, very low traffic volumes. One of the biggest things that makes a chip seal not perform well is to not have a clean aggregate source. So we want no clay and minimal dust. So when I say minimal, I'm talking about like less than 1.5%. Like we were talking about earlier with the fog seal, if you have a dusty, dirty roadway and you put that fog seal over the top, there's a barrier between the glue and what you're wanting it to stick to. Okay? Same thing with stepping on fresh gum with dirty shoes. If you have nice, new, clean shoes, you step on the gum, it's all gummed up in there. But if you have old, dirty shoes, it doesn't affect you so much because it doesn't really stick. Same thing's happening here. If we have dirty, dusty aggregates, it's not going to stick to the binder that we're putting down. So when you see major problems with chip seals, I would say 90% of the time it goes back to an aggregate source that has too much dust. And that dust is a barrier. Now, when you are doing a chip seal, I recommend doing some quality control testing so that you can monitor that dust content and also know that when you move aggregates around, you move a stockpile, you load it with a front end loader, you move it from point A to point B, you put it in a truck, that truck drives to the job site and it comes out of the truck. You can create up to 1% dust depending on your aggregate type, just moving it around, and all of those particles abrading against each other can create additional dust. So optimally, if you were to test the gradation and check the dust content, you want 0.5%, maybe 1% at most on the front end of that process because it's going to generate more dust as you go through the construction process. Or you could do your quality control testing at the site, just before it gets placed, it's gone through all of those other steps, then check it, see what your dust content is. So make sure that your aggregate is compatible with binder. That can be an issue. It should be something that's stripping resistant. We really want that oil to bond to the aggregate. And then finally, moisture can be an issue. It's not so much an issue for the emulsion products if it's just a little damp. Emulsion is half water anyway, so it's not that critical. But if you're using an actual hot PG graded binder, moisture is going to be an issue. So things to do, If you can, store your stockpiles on a paved or sloped surface to let it drain well. You don't want the aggregates to be too damp. You want to avoid contamination and, of course, dust. Dust is the #1 issue. In terms of project planning, we've got to prepare the roadway, and if we have maybe there's a base failure, some low spots, the car kind of wiggles when you drive over because there's a soft spot there. Could just be subgrade, could be maybe there's a water line there and there's a little bit of a leak, but for whatever reason you've got that low spot. A chip seal is not going to be substantial enough to bridge that, so you need to fix whatever needs to be fixed before you start the chip seal. If you're trying to cover up a surface that's really deteriorated, you may want to mill that to get down to something that's fairly level, seal any cracks, fill those before you start, and then make sure you sweep the surface and get it nice and dry and clean. The chip seal process is best done when it's clear weather, warm, hot. Summertime is a great time, but the minimum pavement temperature should be 55 and rising. And so that's I would target that as a nighttime temperature, be your 55. Humidity can be an issue, and it says here, the guidelines will tell you no more than 50% humidity, but if you live in the South, you're not going to find many summer days that have less than 50% humidity, so take that as you will. You don't want a lot of high winds. You don't want that emulsion to be blowing everywhere. You'll also have to check your height of your spray bar accordingly. You don't want that, blowing the aggregate as it drops out of the chip spreader. So also no rainfall immediately before or after. We don't always know, but as best you can check the forecast and go accordingly. That's your best option. All right, so chip seal construction. How does this actually happen? Well, in the picture you can see up ahead, there is the distributor truck with the spray bar on back. That spray bar is spraying the emulsion and putting a nice thick coat, not too thick, but a nice coat of emulsion down on the surface. Immediately behind that comes the chip spreader. So this is the aggregate getting dropped on top. Notice that behind the truck is the emulsion, and in front of the chip spreader are where the chips are being dropped. So what that means is there's no traffic on the roadway in between the oil and the rock. One happens right after the other. The distributor truck has to apply that steady, even coating of binder, so check your design rate, and these rates will be quite a bit higher than what you would see for a fog seal because we're wanting more oil on the roadway. Make sure your truck drives at a consistent speed, because if you've got that spray bar set and you're speeding up and slowing down, some areas of the roadway will be getting more binder than others. And then we're still going to target that single, double, triple, where the bottom of each fan is actually seeing just a little bit of that triple overlap. Here's a good close-up of that spray bar. We've got all of the fans, the nozzles are twisted at that angle so they're not hitting each other, and they're all consistent. None of them appear to be clogged. And then right out here on the outside, this one is knife edge so that we're getting a nice edge and not a lot of overspray with the binder. From the other side, you can also see those fans, how they do overlap. And then that outer nozzle, of course, is a little bit closer to that 90-degree angle from the bar. Right behind the distributor truck, then we've got the chip spreader, and it's got the spreader that's going to drop those chips the exact width of what that distributor truck spray bar was. So we're covering all of that fresh oil with the rock. Those rocks need to drop in. They need to embed about halfway. So that means I've got to calibrate this chip spreader and make sure that I'm getting one single layer of rock. If I get a lot of extra rock that's falling, then if I have a rock that falls and it only hits another rock, it never touches the binder, it's not glued down. That's loose aggregate, which means it's going to end up in the ditch. It's going to get brushed off later. It'll end up in someone's windshield. Not what we want. We want the aggregate that we're paying for to get embedded and used and stuck down to the roadway. So our chip spreader needs to follow the distributor truck pretty closely because, again, there's nothing else that needs to be happening between the oil and the rock. So no more than about 90 seconds. And also remember, this is going to be a rapid set emulsion. So we want it to set very quickly, stay up on top of the surface, and be ready to take on those aggregates right then. And then we want it to set fast, hold on to it, and do its thing. So no more than about 100-foot gap between the two. Again, your chip spreader is going to make one layer of aggregate. Any more than that, you're going to have not good enough embedment. You're going to have a lot of extra that you have to clean. Lever and wedge. If you have a lot of long, thin, platey types of aggregate, sometimes those will get lodged in at weird angles, and then a long, skinny aggregate sticking up, when it gets pressure on it, it'll kind of pluck some other particles out of the way, so it won't end up covering the binder. But if you don't have enough aggregate, you're not going to cover all the aggregate or all of the binder at all. So make sure everything is calibrated, and you can use that carpet square technique just like you did for the binder. I've got a little video here of the process. The distributor truck is moving forward. And then right behind that, the chip spreader comes along, dropping one layer of rock. And again, that aggregate should be fairly single-sized. And then notice the dump truck that's filling the chip spreader is going backwards and dumping into the hopper. So the truck drivers have to be able to do all their work backwards. Now, haul trucks. You got to make sure that you have enough haul trucks, because you could tell that paving train was moving along pretty quick, much more quickly than a traditional hot mix paving project. So on your haul trucks, keep in mind, where are they? They are the next vehicle behind the chip spreader, so they're on that very fresh chip seal. We want this to be as spread out. We don't want any turning movements. We don't want anything that's going to tear that surface. Those aggregates need to seat, and they need to be rolled in. So tandem axles do help kind of spread out that load, but also those are typically the bigger trucks, and you have fewer hookups that have to even happen. More capacity and less driving on the new mat. Make sure, again, no sudden braking, no sudden turns. That's going to pull the aggregate out of that binder, and you'll have kind of an ugly spot there. So make sure your drivers are aware that that's how that needs to work. And then watch your truck tires as they're leaving the job site. Make sure that they're clean. They're not picking up any of your binder, or sand them if you need to keep anything from sticking. But they should not be picking up your binder and carrying it off with them. And then make sure your trucks are not spilling extra chips as they pull away from the spreader. You don't want piles of extra material. Aside from the cost of it, it needs to be somewhere further down the road. It's also a mess that's got to be cleaned up. And then if possible, if you can stagger those wheel paths to keep compaction pretty even, because this is the first time that we're getting compaction of this layer under the wheel paths, because that's where the trucks are. So they are the first shot at getting this stuff all stuck together. Okay, so here's just some more pictures of your haul trucks on that new surface, and you can tell, especially in the bottom right picture with the lighting, you can tell where those wheel paths have happened and how you get a little bit different texture where the trucks have already driven across. Now the rollers, the last step is to get all of this mashed down in place and lock that aggregate into the oil in the surface. So you need to use pneumatic rollers, not a steel roller that can crush the aggregate, and a relatively lightweight pneumatic roller. We're trying to just push these aggregates around enough to stick them down in the oil, make them stay put. We also need the rollers to stay pretty close to the chip spreader, especially when it's hot weather. Remember, we're using a rapid set emulsion, so we need to get in there, get this stuff done, get everything in place, so as it's curing, we're not trying to move particles around. That's going to be even more so in the middle of summertime. Your pneumatic rollers need to have a smooth tire tread, even tire pressure. That's an important thing. So check them all. There's several of them there. And then use at least 2 rollers so that you can give multiple passes and be able to keep up with the chip spreader. And here's a couple more pictures. You can see how that gets rolled in, and then you'll stagger those pathways as you move forward and backward for the different passes. Make sure that all of it is getting compacted and seated within the binder. Now, at the end of the day, you need to quit, and this is a pretty continuous process, so it's hard to start and stop, but essentially you'll turn off the spray bar and you'll drop those last bits of aggregate, but you've got a little bit of a messy ending there. So the next day, you need to come in and be able to pick up where you left off, and you don't want to see that intersection that looks kind of yucky. So you can put down paper joints. So you put down the paper, that's going to make a fresh edge. And then the next day, you can start right on that paper edge. So the spray bar starts its thing, and then you'll pull that back and have a nice clean edge, and that's where your chip spreader will start. Now that helps keep the oil off of the work that you did yesterday, because again, this is an aggregate surface, not an oil type surface. Then also brooming. Usually you're going to use some type of a mobile pickup broom, something to sweep that surface. We're going to use that before to make sure the surface is as clean as possible. We might use it a little bit during, and then for sure we're going to be using it after. It needs to pick up the loose chips, not just sweep them off into the ditch. But before you broom this, you need to make traffic slow down. That is the hardest part of any chip seal project. As soon as there's something on the surface, people that live there think, well, I got to go home, I got to go here. So they get on that roadway. They don't really want to slow down. It says that we should limit traffic speeds to 15 to 20 miles per hour. And that, I'm sure some of you are laughing right now because that's just not an option. So put up signs, talk to the neighbors, the folks in the area, let them know what you're doing, try to explain this. But this is when you're most likely to have rocks in the windshield, because there are still going to be some extra chips that are there. There will be some shedding. We need to get that cleaned up, but we can't get on it too soon or we'll start peeling some of the aggregates out of that binder. We need to let it set. We need to let it cure a little bit. So there is that intermediate period where it's difficult to work with, but it's fine for traffic to be on it, just not optimal for them to go too fast. And rocks in the windshield are one of the most common issues. So put up a sign, slow, we've got loose gravel. One agency that I know of puts up signs that say fresh oil, and they said that slows people down more than anything. And technically it's true, there is fresh oil, it's under the rock, but it is there. So whatever works, however you can get folks to slow down, that's great. But putting the broom on it for a hot applied chip seal, that's going to be pretty quick. Within 30 minutes, it's cooled down enough. You're not going to pluck too many of those aggregates out. But for an emulsion chip seal, it's more like a 2 to 4 hour thing. So usually at the end of the day, your broom truck will go through, kind of sweep and clean that up. Make sure your bristles are not so stiff that they are pulling aggregates out of the surface. And then you're going to have to go back a week later, a month later. Usually there will be some shedding for up to a month, but that's also a function of how well calibrated your chip spreader was. So in this example, you can see there's a lot of loose chips. We really can't see any binder at all. And I can see lots of places, if we look up close, lots of places where I've got chips on top of chips that are clearly not seated in any binder. Those are just loose. So not only is that a problem for safety for drivers, chips in the windshield, all that kind of thing, but it's also a waste of money because that's a lot of material that could have been used somewhere further down the road. This stuff's not cheap, especially when you're buying a certain size fraction of material that's clean enough to be used for a chip seal. It's not cheap. And then a finished product, everything is rolled in and nice and tight, and it looks good. It does not look like a newly paved road, but it's pretty good. And if you've had a gravel road before, it's a definite improvement. But then over time, especially if we stripe this, we give it some time, it starts to look like an aged asphalt pavement. So a lot of the general traveling public really doesn't pay attention to the difference. They don't know so much or don't think about it. So it makes a nice usable surface. Now, in terms of troubleshooting, what are the things that can go wrong? Well, we can have excessive loss of aggregate. Sometimes if it's too cool, the weather's too cool, it doesn't stick. If your surface is too wet or if it's too dusty, things don't stick. Did you have contamination of dust or fines? And sometimes traffic control issues, we get folks on it too quickly, they're going to pull those aggregates out of the surface. And then maybe we just had an issue with binder and aggregate not being compatible. Hopefully we know that in advance. Now, sometimes we have binder pickup. Make sure your aggregate was covering the binder, that you had the correct binder, it was at the right temperature, and make sure your application rate was not too high. Sometimes if there's too much, it'll sort of ooze through the rocks and get to the surface, and then you'll start having traffic pick that up. And if you have an uneven surface, sometimes you'll see streaks or ripples. Make sure your distributor truck does not have a clogged nozzle. Make sure you didn't have any spreader gates on the chip spreader that were clogged. Make sure that the speed on your construction vehicles were all consistent. And then if your chip spreader is too high, sometimes you'll have chips that hit and then they roll and bounce around, and that can develop a little bit of a pattern. We don't want to see that in the surface. Or maybe the chip spreader is going too fast. If you have a wave of binder that forms in front of the chips, your binder rate is probably too high. So some of the things that can go wrong, things to use for troubleshooting. Now, cost and benefit. This, again, a wide range of values. Most of the difference here is going to be related to whether you do this in-house or you contract it out, and then also whether you use an emulsion binder or a PG graded binder. Those will definitely impact the cost. The aggregate source is also a big one. If you have a local aggregate source that gives you the sizing that you need without a lot of dust, then wonderful. It's probably a pretty good cost. But if they have to use air separators or washed fractions or something like that to get a good aggregate source for the chip seal, the price is going to go up. Now, for lower traffic, when you put this on a roadway that's already in good to fair condition, you sometimes can get as much as 10 to 15 years. I was on one roadway that they had not done any maintenance on it in it was like 28 years or something. It was unbelievable, but they had done a good job in the beginning, didn't have a lot of traffic, and it just lasted and lasted and lasted. So that was great. Higher traffic, if you've already got a good asphalt surface in good condition, you might get 8 to 10 years. A more common typical thing, if you've got a county road that's always been chip sealed, there's not an asphalt surface underneath it, you're probably going to get somewhere in the neighborhood of 7 years, a little more than that for low traffic, a little less than that for higher traffic. And again, this is in the context of local agencies. This is not, downtown Dallas or anything like that. All right, there is a related treatment called a mass crack treatment. This is very much the same as a chip seal, except we add a step and we use a broom sled to force some extra binder down into the cracks of an existing surface. So it's the same concept as the chip seal. We're spraying binder over that surface that's aged. That's going to provide some closing up of helping with the oxidation, closing up any small cracks. But if I have a lot of those cracks, maybe it makes more sense to not just cover them up, but to force binder down inside to kind of seal those cracks. So we said earlier, if you've got a lot of cracking, you might want to do some crack sealing prior to starting this project. But with a mass crack treatment, you can do it all in the same process, which is really nice, saves a lot of time. Crack sealing is one of the most labor intensive maintenance things we can do, and it does leave your workers out in traffic, a lot of traffic control needs, and that kind of thing. So for a mass crack treatment, you might hear it called a scrub seal. We're essentially spraying a little extra binder down and then using a broom sled to push that binder down into the cracks, but also leave enough on the surface to handle our chips. So in that way, we fill the crack, we also seal the surface, then we drop those chips. So in terms of cost, it's not a whole lot more, except that you will be using additional binder and you do have to have the broom sled. So this is what it looks like. You can see that broom sled with the different angles of the brushes. You do want to keep an extra little wave of binder in front of that broom sled so that you know that you're pushing enough binder down into the surface, but also leaving it up top to catch those aggregates. Here's a video. Hopefully this will translate well. You can see the existing surface there had quite a bit of cracking, so not in great shape. And we're going to come behind that, looking at some of those cracks. Sorry for the shaky camera work. Now you can see, even after the binder is placed, you can still see where those cracks were. Then the broom sled goes behind, forces the material down into the cracks, and then we come immediately behind that with the chips. Another variation on a chip seal is something that we call around here a hybrid chip seal. And this is where we have some existing pavement. And the first project we did this on was an older asphalt pavement. I would say at least 20 years old. It was pretty good in terms of overall structure, but a lot of weathering, some thermal cracking, quite a few cracks there. So we came in and did a regular single chip seal with 1/2 inch rock. On top of that, we came in with another layer, did a 1/4 inch chip seal, so a smaller surface type aggregate to make it a little bit smoother. And then on top of that, we came in with a fog seal and put over the top. So that effectively painted it black, but also helped with chip retention for that top layer. So this was the project. The right lane, you can see they've done a lot of crack sealing, trying to get ready for this. Lots of cracking, but most of it was down the middle of the lane, so not so much of the in the wheel path type cracking. So again, this is more of a non-structural issue. And this is what it looked like after. So a 1/2 inch chip seal, 1/4 inch chip seal, fog seal, and then the nice striping on top. So when the project started, these folks had had an asphalt roadway, and then that first layer of chip seal went down, and most of them were pretty upset that we were turning their road back to gravel, which is a common complaint. But when they finished the project, those folks were very pleased with how the road looked, how it drove. It was smooth enough to suit pretty much everyone except bicycles. Bicycles weren't real thrilled with it because it wasn't quite as smooth as an asphalt mix. So, all right. Questions?
Yes, we have had one question come through. Is there a difference between a chip seal and a cape seal, or are they the same thing?
They are not quite the same thing, but a chip seal is part of a cape seal. So I will actually address that when we get closer to the end. It's going to be a combination treatment. So I will go over that just a little bit later. So I'll say hang on for right now.
Sounds good. Well, I believe that is everything we have at the moment.
All right, next we will look at slurry seals. So I will pop the poll question up here about slurry seals. Let's see how many of you are familiar with those. I think a number of years ago, lots of folks were using slurry seals. They've become less popular and they're gaining a little bit of traction now from what I've seen. We got a few more still to vote, but right now it's 40% yes, 40% no. Oops, changed. Now we've got about 25% who have said somewhat. So the majority is at least somewhat familiar with these. So I'm going to go ahead and end the poll. So you should see the presentation again on your screen. A slurry seal is a mixture of asphalt emulsion, a dense graded aggregate, mineral filler, water, cement, or some type of lime additive, something that's going to give it a little oomph. And this is just really a thin surface treatment. Again, we're not looking at things that are going to correct a lot of structural issues, but this is a very thin layer. So the largest stone is pretty much how thick this layer is going to be. And that ranges anywhere from an 1/8 inch up to 3/8 of an inch. So this is pretty small stuff. The emulsion that's used in it is typically a conventional, maybe a polymer modified emulsion, but it's just your traditional normal type of emulsion. And this can be a slow set or a quick set, depending on what you want to do with it, what your traffic control is like, what the area is like, the weather's like. So you do have some options here. So a slurry seal is good for projects maybe where you've got a raveled surface, an oxidized surface, something that you want to waterproof, seal some small cracks, maybe a little bit of raveling, and it can actually add some skid resistance. If you have a location, maybe you've got curb and gutter, or you've got maybe an overpass or something where you are height restricted or even weight restricted areas, and you've got to maintain a certain level. Maybe it's a drainage issue and you've got curb and gutter and you really don't want to mess that up and you don't have enough funding to redo the entire project. This is something that's a very thin layer. It's not going to mess up your drainage paths, but it will be very effective at slowing down the surface aging. It's good pretty much for all traffic levels. And typical life, they advertise up to 15 years, but in just talking to people, I think 5 to 6 years is a pretty good estimate for the extension that you get. Now in the picture, you can see the two sides of the road that have been placed. The left side, kind of that bottom left, is a black color. The top right is still brown. That's the emulsion before it breaks. So that's a great representation of those two different colors. And this is the process in action. So all the materials get mixed together in this hopper, and then everything gets pushed to the back, and it's not really like a paver, but a little bit. Everything is mixed together, and then an auger spreads it out, and then you've got this burlap drag that sort of smears it onto the surface. I don't know if smears is a nice technical term, but that's kind of how that works. Now, preparation, we've got to do any crack sealing, patching, anything. Because again, with something this thin, we're not going to be able to bridge any structural issues or cover up a lot of problems. So if there is a problem, fix it before you put the slurry seal on top of it. Make sure that if you do crack sealing, that you think about any curing requirements. How long does it need to cure before you put something on top of it? And then when you're ready to do the slurry, make sure the surface is clean and dry. Now for this one, it is definitely recommended that you remove the thermoplastic pavement markings. And then if you have any utility inlets, that kind of thing, manhole covers, all of that, you can place roofing felt over those inlets and then remove that later. This is another activity that you want to do in optimal weather conditions. This is a warm and dry summer type thing. Your emulsion's got to set. It needs that evaporation. So sunshine and warm temperatures is definitely going to be a help. This is not usually something that you want to do at night, primarily because your emulsion is going to take a lot longer to do what it needs to do with curing. You also want to make sure you have no freezing conditions for at least a couple of weeks after you've placed it. In terms of construction, the machine, you've got a hopper, you've got all of the different parts, your aggregate, your additives, your fines, and then it's got a little pug mill in here that's going to mix it all together as it comes through the gate, and then it goes down through the chute into your spreader box, and that spreader box is kind of like the auger on the back of your paver. It's going to spread it out and kind of place it like a screed. Note that the edge of your spreader box needs to be just outside the paving line. Okay, you want to make sure that you have a smooth surface because this is just a burlap drag that goes over it. So whatever gets placed is pretty much what you're going to end up with. So make sure that your process is consistent, your speed is consistent, and you want to do as little handwork as possible. There are some folks that are really good at it, but in general, the more you mess with it, the more you kind of mess things up. So if you can get that process lined out, make it very consistent, you're going to get a better overall product. You do need to roll this in, make it nice and tight against the underlying surface, but you want a light pneumatic roller, nothing more than about 6 or so tons, and 1 or 2 passes is enough. That will take multiple passes probably to get the entire surface, but coverage is what it's referring to there. And then sweeping and sanding. Make sure you wait and open it to traffic at the right time. You don't want traffic to pick this up. Make sure that cohesion has developed, definitely after everything has turned black and you've got enough curing that's happened that you're not going to have traffic picking it up. If so, you'll need to use a blotter coat. I've got a video here. It's the auger that's mixing that all together, that little pug mill, and then it's just a very thin coat that comes out underneath. So again, super thin layer, but it is a surface treatment. We're applying oil to the existing surface. We've got a little aggregate there for texture, stability, mainly texture. And then in terms of troubleshooting, if we have an uneven surface or washboarding, make sure your spreader box is set up correctly. You may need to add weights to kind of hold that down and make it move smoothly across the surface. If your mixture is too stiff or the emulsion breaking too fast, sometimes that will affect the smoothness. And if your ambient temperature is too high, sometimes that makes the emulsion set up too fast and you'll get that same effect. If you have raveling, then the mix might have been a little bit too slow to cure. You might have had too many fines. Traffic could be on the mat too soon, or it could be that it's just going too fast on that fresh mat. In terms of cost and benefit, we've got somewhere in the range of 350 to 570 per square yard, or in terms of lane miles, that's 25,000 to 40,000. The cost difference is definitely going to depend on the type of emulsion, any additives that you have. That mineral filler is going to give it a little bit of substance, kind of stiffen it up a bit. Cement and lime can do the same thing, but all those things are going to have different costs. And then whether you do this in-house or if you have it contracted out. Down at the bottom of the screen, you can see some expected life extensions. For lower traffic on a pavement that's already in pretty good shape, you might extend another 8 to 10 years. Higher traffic, 6 to 8 years. For an aged, fair condition, 6 to 8 years, 5 to 7 years. Now notice that all these things that I've shown you, these are surface treatments that are best applied before your pavement has reached the end of its life. This is not a magic fix that's gonna add 8 to 10 years after the pavement has already failed. It's only gonna add that extension while you still have good structure. So there's no line on the table for a pavement that's in poor condition, because this would not be an appropriate treatment. All right, next is microsurfacing. I'm going to put that poll up here. And you know what the question will be. Are you familiar with microsurfacing? All right, almost half of you so far have said yes. Got about 25% that said no, and the rest said somewhat. It looks like the voting is slowing down a bit, so I'll go ahead and close that out. All right, microsurfacing is essentially the same thing as a slurry seal. It's just a high performance version of that. So when you look at the pictures, the process looks very similar to what we saw for the slurry seal. The differences are that you can lay this 2 to 3 times the thickness of the largest stone in the mix. So if you had 1/8 inch aggregates, you could place this 3/8 of an inch. If it was 3/8 of an inch is the largest stone, you can get, 3/4 of an inch or so. This is something that's a little more substantial. It's a little bit thicker, and it has a little bit better capability of being able to correct some minor profiles of irregularities in the surface. So it's more durable than a slurry seal, and you can place this in multiple layers. A traditional slurry seal, 1 layer, that's the shot, you're done. But with a high performance type, you can come in and do multiple layers on purpose, at that same time. So a lot of times what folks will do if they've got some minor rutting, they might come in and place a scratch course to fill in some of those low spots, and then put the surface course over the top of that to finish it out. The thing about microsurfacing is that the emulsion is always polymer modified, and it is a quick set polymer modified emulsion. So most typical, I think you're going to see about a 1/4 inch aggregate here, up to 3/8, but 1/4 is more common. An 1/8 inch is really small, and that's more typical of the traditional slurry seal. Now, microsurfacing is not a crack treatment in terms of fixing cracks, and it doesn't really prevent reflective cracking, but it is going to provide you a little bit more substantial surface while also making that surface impermeable, and again, not repairing cracks, but keeping them from getting worse. So if we get to it soon enough, then we're going to keep those cracks from getting worse, because we're covering it up. We're not allowing the water and the air to get down into those cracks at that point. The time to place this is very similar to slurry seal, warm, dry conditions. You don't want any rain, high winds. The additives in it, though, with that polymer modification, do make it a little bit more weather resistant. So it's more applicable if you wanted to do a project like this at night, a little bit cooler temperatures. And this is something, since we do have a little bit more structure to it than the traditional slurry seal, it might be something that you use on a location with a little higher traffic, in which case traffic control is a bigger issue, and sometimes night work is the easier way to go about that. So this is something that will allow you to do the project in the overnight hours. And then with those additional polymers and the quick setting product, you can get this back open to traffic within about an hour or two. Project selection, again, where do we want to waterproof the surface? Where do we have small cracks that we can seal up? We can fill in some minor rutting, do some leveling, and this will add some skid resistance. So any raveling, irregularities, places where the surface is not really a bad structure, but it's just looking a little ragged, and we need to get that fixed and prevent worse problems from happening later. And then of course we get that new surface. It's going to have the nice dark appearance so that our striping looks nice and bright. We get better visibility, so there's a safety aspect to that as well. In terms of cost, we're going up a little bit in cost because we're giving it a little something more. So 60,000 to 100,000 per lane mile. Again, lots of variability, different parts of the country, whether you do in-house or not, or contract that out. So a pretty wide variety, but still much cheaper than an asphalt overlay traditional. So life extension, you can see we're giving it a little more oomph. We get a little bit more out of it. So in our lower traffic setting, a good to fair condition roadway, 10 to 12 years. Aged fair condition, probably 6 to 9 years. Then for higher traffic, you'd bump that down just a bit. All right, I'm going to go ahead and pause here. Are there any other questions that have come in?
Looks like at this time we do not have any further questions.
All right, very good. We'll go on and talk about the ultra thin bonded fairing cores. And I know a lot of you already had mentioned this is the most popular one, so I'm going to assume that most of you have seen this or know a little bit about it. So I'm going to skip over the poll question and go into what this actually is. So this is a multi-layer system that gets placed all in one pass. So the first layer is a polymer modified emulsion membrane, and then we put a gap graded hot mix on top of that. So it does take specialized equipment. You can tell in the picture, this is a bigger operation, more steps. So we're getting closer and closer to a traditional overlay. The thing that's different about this one is because we're placing that membrane first, you have to do this one with a spray paver. So in the midsection of the paver, there's a little area that sprays that membrane just ahead of where that asphalt mixture is being placed. Now the asphalt mixture is still a thin layer of mixture, but it is a gap graded mix, which means we've got some larger rocks, we've got the small rocks, but we don't have much in the way of the middle sized rocks. So it gives you texture. It leaves some spaces open within the mix, and that's something that typically is going to help with, can help with noise and definitely splash and spray. But it's a pretty thin surface, so we can get a nice new fresh topper on that surface and still maintain a lot of our drainage and all those types of things with that vertical profile. So matching curb is a lot easier because this is something that's going to be maybe 5/8, 3/4 of an inch thick. So we're not doing a lot of vertical changes. Now this is a close-up, not the clearest picture, but you can see right under here, right before the mix comes out, we've got this application of the membrane. So that spray paver has this membrane that gets placed just ahead of where the mix is coming through through the tunnels and all that. And then the auger spreads it out from edge to edge. Again, this is a little bit more than what we would see, a little bit more substantial structure than we would get from microsurfacing. because we're completely waterproofing that surface. That's going to seal some moderate level cracks. So when you're starting to see a pavement that's in a little bit worse condition than what we've used for those other treatments, this one is going to be able to handle a little bit more in terms of the cracking severity. It is going to be that open graded material, so we're adding skid resistance. We're correcting some surface irregularities. Again, splash and spray gets better. But since we can fix that surface, it's going to help with raveling and minor rutting. And it's also going to use that layer, that waterproofing membrane, to help slow down reflective cracking. So when we might see, a slurry seal, if we place a slurry seal over an asphalt pavement that's got a good size crack, we're going to see that again. It's going to show up in that next layer. But with the ultra thin, it's going to be a little slower to work its way through because of that membrane inner layer. That membrane prevents water from getting in there. It's going to bond a stronger bond with the underlying surface than what we see with some of the traditional emulsions. The common thickness, again, 5/8 to 3/4 of an inch, and you can use up to 1/2 inch size aggregates. So the lifts that you would place are going to be somewhere in the neighborhood of 1.5 to 2 times the largest particle in that mix design. And we're getting closer to something that's going to be designed more like an asphalt mixture. To compact it behind the paver, we're going to use a steel wheel roller in the static mode. We're not really trying to beat it into place or get a lot of density. We're just trying to get it to seat really well, get those particles to kind of move around and lock together and make it very smooth. But our goal is not really high density, so to speak. And then when it gets down to about 150 Fahrenheit, we can go ahead and open that to traffic. It should be stable enough to let some minor traffic on it. I will say that you should wait longer if you have a lot of big trucks, heavy vehicles, a lot of turning movements. There was one place locally, and it worked great everywhere except right by a truck stop. And so when those trucks came out of that gas station, got over to the light, then they were starting with that heavy load and making a turning movement across the new pavement. That was where there were some places where the surface would tear when they let the trucks on it too early. So that would be my one caution. So these ultra thin type treatments, again, static steel wheel roller, smooth it out, wait longer for those heavy vehicles and turning movements. But weather applications, again, this is a summertime activity, 60 degrees minimum pavement temperature, clean and dry surface. So that's a common theme with pretty much everything we've seen. Now, some of these types of things we have, like Nova Chip, there are some proprietary mixes that may kind of fall in fact, in the micro surfacing and in the ultra thin world, there are some proprietary specific types of mixes that typically relates to specifically what's in that membrane. So there'll be some brand names that go along with this that you may have heard of. And then in terms of cost, we're getting a little more out of this, so we can expect it to cost a little more. We do have that polymer membrane. That's going to be a more expensive portion of it. So now in lane mile costs, we're looking at 100,000, maybe 135,000. And I feel like this is something that it's not really limited in terms of traffic. So even though this whole webinar is more in the context of lower traffic, middle type, moderate traffic levels for local agencies, this is also something that you see on freeways and very high traffic arterial type applications. So we're getting a little more bang for the buck, but also more bucks. So somewhere in that 100 to 135,000 per lane mile. But part of the cost comes in because this will most often be something that has to be contracted out. So unless you do a lot of this and you invest in that equipment, you are going to have to pay for a contractor to come in and do this that has the spray paver. So if you, a lot of times local agencies have small projects in the grand scheme of things, and bringing in a contractor, you're paying for all the mobilization costs, and then your project is maybe not that long. Overall, your cost per mile will be more. So one of the strategies would be to, maybe if you want to try this, get a selection of locations. Maybe it's a mile here, half a mile there, maybe it's a neighborhood, but try to group some projects so that you're paying for one mobilization cost, but getting a lot more area of pavement down on the ground. So in terms of life extension, 10 to 12 years, higher traffic, 8 to 10 years. And then for a fair condition, maybe 7 to 10 years for your lower traffic, 6 to 8 for your higher traffic. And again, this is also an appropriate fix for some things that have even higher traffic than what I'm generally considering for this local agency style of thing. All right, next we will talk about thin hot mix overlays. So I'm going to go ahead and pop this poll question. Does everyone know what thin overlays are? Are you familiar with those? All right, that was pretty quick. Looks like most everyone has voted. 60% of you have said yes. Less than 20 of you have said no. I'm going to end that and we'll go back to the presentation. Now, a thin hot mix asphalt overlay or asphalt mixture. This is basically the same thing as your traditional hot mix layer, except that it uses smaller aggregates. A lot of times these will be referred to as thin lays, but it really is a functional hot mix overlay. It's designed specifically to prevent rutting, resist cracking, have durability, skid resistance. So when you start thinking about the traditional asphalt mix design, all of those things apply here. It's just a miniature version of that same thing. There are different types of mixes. You can have dense graded, gap graded, open graded. But again, the difference is just the size of the aggregate. So it's a miniature version. For a typical traditional hot mix overlay, the surface aggregate might go up to a ½ inch. This is going to be half of that. So up to a ¼ inch. And there is actually in all the AASHTO design guide things, 4.75 millimeter super pave is included in that. So that whole procedure, again, it's just the miniature version. Now, where this really comes in as providing us some savings is that the lift thickness. When we design an asphalt mixture, we get the best compaction properties when we place it somewhere between 3 and 5 times that largest aggregate. So a traditional mix with ½ inch aggregate, 4 times that is 2 inches. That's why your typical overlays are going to be 2 inches thick. This is half the size. So now what we're looking at is smaller aggregate particles, and the typical lift thickness is somewhere between 3/4 of an inch to 1 inch. So less material can cover a larger area or a longer length, and everything else about it is pretty similar. So I can use this as a leveling course. In fact, some folks will use this strictly as a leveling course and then go ahead and put a 2-inch traditional overlay on top. But one of the advantages of this is in some areas, when the super paved mix design started for our traditional mixes, we started using some coarser gradations. So quarries that were crushing different types of aggregates to go in those asphalt mix they were using less of the screening, so those smaller size particles. And so they had a whole lot extra and they were looking for a way to get rid of them. Well, this is a great way to use some of those. So using those screenings and being able to incorporate those into an actual mix design, that's great. And because the particles are smaller, we get a really smooth surface, reduced permeability, everything's nice and tight. And so then there was some concern about, well, if everything's so nice and tight, are we going to have trouble with skid resistance? And I did a research project on this, and it's actually as good or better than our ½ inch traditional mixes. So all of that micro texture in the aggregates really helps a lot. And there was no downside in terms of skid resistance. I'm sure there's some aggregate type that might have a problem, but the same would be true for the traditional style as well. Now, because this is going to be placed in thinner layers, it's still not going to do a whole lot of good for any significant structural cracking. That thin layer can only cover up so much, and so if you have any roughness that's in that underlying layer, you're going to see that reflect through. So again, this is just like anything else, but the difference is you've use less material, it goes twice as far, but you can't just cut the cost in half because all of your handwork, your labor, and that kind of thing, you've got all of that for twice as much of roadway. And also because you have smaller aggregates, there's a little bit more surface area, so you'll have higher binder content for this 4.75 or quarter-inch thin lay. So overall, I would say on average, that cost ends up being about 2/3 of the traditional overlay. The other thing was the first project I was involved in, this picture right here, this is the roller going over the material after it's been placed from the paver. The screed does a lot of the compactive effort, and this was the first pass of the roller, and you can see no roller mark whatsoever. So not a lot of roll down, and that was one of the things that really surprised us. So we ended up getting thicker final lift thicknesses than we had planned, expecting it to roll down quite a bit, and it didn't. So this is going to be somewhere in the $80,000 to $120,000 per lane mile, and you can get some significant additional life out of that. And then here at the end, that traditional overlay, this is the kind of thing that you're probably all familiar with. So I'm going to kind of skip through that because that's not really the point of this, but just as comparison, you'll have these slides to go back and look at. But 2-inch typical surface layer and normal asphalt type things. So we're back to what's normally done. But all these other treatments that I've told you about can be a surrogate for having to spend the money for that true traditional overlay, because that is not cheap. It's a big process, but think of it as, that we're kind of getting into the level that that thickness could be a lot of structure for a given roadway. So cost wise, we're up closer to the $180,000 per lane mile range, so that is significant. And that number just seems to go up every year. So it depends on oil prices, where your project is with respect to the plant, in-house versus contract work, all that kind of thing. So now, combination treatments. This is the last thing I wanted to go over real quick. I know we're about out of time, but if you have problems, fix those problems before you put something on top of it. So crack filling, sealing keeps the air and the water out. That's critical. If you have base failures, fix those base failures before you put something on top of it. I promise you will eventually see it again if you don't fix it now. Profile milling. This is one way to get everything nice and smooth. Any surface treatment that you put down is going to be a function of the smoothness of what's underneath it. So that's true of a traditional overlay, but the thinner the layer is, the more quickly you're going to see those deviations show up. And sometimes you see it as you're placing it. So if you have rutting, you have some cracking, you can go in and do some profile milling. So choices are either level it up and fill in the low spots or scrape off the high spots. So profile milling will do that for you. So any of those things combined with your surface treatment technically would be considered a combination treatment. A scrub seal is considered a mass crack treatment. So we're treating the cracks, but we're also placing a chip seal. Technically, it is a combination. And the cape seal, this was the question that was asked earlier. This is a chip seal or scrub seal, but then a slurry seal goes on top of it, or you could substitute that with microsurfacing. So a cape seal, typically we'll use that chip seal to be an inner layer to kind of break up anything that might allow flushing too much binder coming to the surface. So you get that layer of aggregate sort of to serve as that inner layer of separation. And then the slurry or the microsurfacing that goes on top of that gives it a nice smooth texture that looks more like what folks might be used to seeing. In a sandwich seal, this is another way to try to mitigate some flushing or bleeding that may have happened. It's a layer of large aggregate and then a chip seal on top of that. And you're getting the benefit of 2 layers of aggregate, so a little bit more structure. And then the hybrid chip seal that I already talked about, the 1/2-inch chip seal plus a 1/4 inch plus the fog seal. And then the last little add-on is just in-place recycling. Smaller local agencies are probably not going to see this. State agencies might, but this ranges from the hot in place, cold in place, and full depth reclamation. And that is my parting statement. So I'm going to go ahead and close that out and let you guys ask any last minute questions that you have.
Okay, I believe that's everything questions wise.
All right, perfect. Well, I appreciate your attendance. When you close out of the webinar, you'll see an evaluation, and I would appreciate any feedback that you have and hope to see you again sometime soon. Thanks so much.